Okay, we're going to take a look at simplifying rational expressions today, basically just multiplying and dividing. So, first thing, rational expressions is dealing with fractions. So we have to make sure that before we do algebraic expressions, you have to make sure you know how to multiply and divide just regular fractions without a calculator. So when you are multiplying, the first thing that you're going to do on a problem like this is look along the diagonal to see if you can reduce the fraction. Kind of like if it had been 4/6, we could have reduced it to 2/3. So you're looking for a number in the numerator and a number in the denominator. Here, nothing can reduce. When that's the case, you multiply straight across. So 2 times 4 is 8, 3 times 5 is 15, and here's my answer. 5/8 times 4/15. Notice that we can simplify the 4 and the 8. It's like having a 4 divided by 8. It can simplify to 1/2. So 4 goes into 4 one time, 4 goes into 8 two times. Now notice the 5 and the 15. 5 goes into 5 once, 5 goes into 15 three times. Now you multiply straight across and we get 1/6. Next one, doesn't matter how many fractions that you have, as long you are looking for something in the numerator, something in the denominator. So for example, I could say, look at this 2 and this 8, and yes, I know I could have done the 10, but 2 goes into 2 once, 2 goes into 8 four times. The 3 and the 9, 3 goes into 3 once, 3 goes into 9 three times. And the 5 and the 10, 5 goes into 5 once, 5 goes into 10 twice. I can't simplify anything else. I multiply straight across. 1 times 3 times 1 is 3. And down here, we're going to have a 2 times 4 times 1, so we have 8, and my answer is 3/8. For the next problem, when you have mixed numbers, you first have to change it to an improper fraction. So we're going to multiply 4 times. This is like having 1 whole and 3/4. So imagine taking the 1 whole and switching it into fourths. You'd get 4/4. Add it to the 3/4 and you have 7/4. The little shortcut is you multiply this part and then you add. Start at the bottom. 4 times 1 is 4, plus 3 is 7, so we get 7/4. 7 times 3 is 21, plus 3 is 24, so we get 24/7. Now you can simplify. So the 7 goes into 7 once, 4 goes into 4 once, 4 goes into 24 6 times, we get 6/1, and of course we would just write that as 6. Now this was just meant to serve as a reminder, not as a concept builder or anything like that, so see me if you need additional help on this topic. So going on to division, for division, we are just actually going to change this to multiply. So you are going to leave the first number the same. We are going to change this to multiplying, and then the number after the divide by sign, we are going to do the reciprocal of that. So we get 5/3. So, I mean, you could think of this like, if you think about 5 divided by 2 would be equivalent to saying what's half of 5. So it's still going to be changing it to multiplying. So we do that all the time without thinking about it, but when we have fractions, all of a sudden it becomes a little more complicated to just kind of think conceptually. So once you've changed it, now it's just like we did before. So simplify those, and we get 5/8 for an answer. When you are dealing with mixed numbers, you're going to change it to an improper fraction first, like I showed you before. So here we're going to have 9/5 still divided by 18/7. Now we can change it to 9/5 times 7/18, and we can simplify. And sometimes you can't simplify a fraction, so don't worry about that if that's the case. And we get 7/10, and that would be my solution. So it looks pretty easy. Well, now all of a sudden we're dealing with rational expressions that have algebraic expressions. So what you cannot do, you cannot look at this and say, oh, look, 25 and 30. 5 goes into 25 5 times, 5 goes into 30 6 times. No, no, no. Do not do that. You cannot cancel part of a sum or a difference. Now, here's why. So this should make sense to you. If you all know that if you added 2 plus, if you're going to simplify this, you know to add first. So you would get 5/8, and that would be your answer. You know that this can't work. You can't do 2 plus 3 over 5 plus 3. and cancel the 3's and say those reduce to 1, and then come up with some answer like 3, 6, because you know that that doesn't make sense. That doesn't work. Well, if it doesn't work here, it won't work here. So what you have to do is factor. So this lesson is really going to be a huge review on factoring. Now, what you can do a diamond problem like we did last year. So if you wanted to, for the numerator, you would have this product is 25 and the sum is 10. So we could have a 5 and a 5. Because it's just an x squared, we don't need a box. So we can say x plus 5 and x plus 5. And in the denominator, now what I like to do, because the only way to get x squared is x times x. And I know 6 times 5 is 30 and 6 plus 5 is 11. So I don't even do the diamond problem, I just think about it. Now, it's factored. So this is like having 2 times 3 over 2 times 5, okay? It's factored, x plus 5 times x plus 5. And then you can cancel. So here, notice that I have this x plus 5 goes into x plus 5 once, x plus 5 goes into x plus 5 once. When they are exactly the same, you can cancel them, just like you would with numbers. So what do I have left? X plus 5 over x plus 6. This is my simplified answer. Done. Next one, we're going to simplify this, a little more complicated. You are going to find this kind of handy. Remember that factoring flowchart. The very first thing on there was, is there a GCF that can be factored out of the whole expression? I think you've seen that a time or two. Notice that we have a 9 that can factor out of the numerator. So I'm actually going to start by factoring out. So don't forget GCF. I'm going to factor out a 9. So when I do that, I get b squared plus 2b plus 1. And my denominator, I can factor out a 3, and I get b plus 1. Now notice I've got a 9 and a 3. I can simplify that. Okay. Now, I might be able to do something more here, so I'm actually going to factor this. I still need the 3. You can do a diamond problem, but I realize the only way to get b squared is b times b. So I'm actually, and the only way to get 1 is 1 times 1. So if it can be factored, it has to be factored like this. Kind of multiply it out, do FOIL, you can see that you get that 2 in the middle. By the way, this is actually a perfect square trinomial. You can see the format for that on your factoring flowchart as well. Don't need the 1, but I'm going to put the b plus 1. And now it's all factored. Notice I've got a b plus 1 and a b plus 1. Those cancel out. So I'm left with 3 times b plus 1. Or if you want, you could say 3b plus 3. And either one of those, this is factored form, this is not, but either one of those would be acceptable. Next problem gets a little more complicated looking, but actually this problem is easier because all of these can be done with simple diamond problems. But you have to factor everything first. So we start by factoring. So up here we're going to have c, let me kind of work this one out here. And if you want, you can do diamond problems. So we have a negative 24 for a product and a 2 for a sum. So it looks like it's going to be a 6 and a negative 4 to give us those values. We don't need boxes on any of these because they're just c squares. There's no number in front. So c plus 6, c minus 4. For this one down here, we've got a 6 and a 6, also a perfect square trinomial. For this one, looks like we have 2 negatives, so negative 6 and a negative 4. So we have c minus 6, c minus 4, and the last one looks like a negative 4 and a negative 4. So we have c minus 4 c minus 4. Once you have everything factored, now I think this part's kind of fun because all you're really doing is trying to find things that are the same. Something in the numerator with something in the denominator that cancels. So I'm going to cancel these. I'm going to cancel this. I'm going to cancel this. And I'm left with c minus 6 over c plus 6. And that's done. Okay, now for this last one, this is division. So remember with divide, we change it to multiply, and then this is going to change to the reciprocal. So you can do that right away, or you can factor it as we go. Now this is where I would definitely want to make use of my factoring flowchart because we have a couple of them on here, the perfect square trinomials. Notice the first term is a perfect square and the last term is a perfect square, and then there's a pattern following in the middle. If you look here, I've got the 16 is a perfect square with that a square along there with it, and the 9 is a perfect square. So I could do a modified diamond in a box, but life will be complicated if I do that because the numbers are really big. So you want to look to see, is it a perfect square? Now because I have a minus here first, if it's going to be that pattern, it's going to be this one. So it's going to be a minus in the middle. So I come up here and I'm hoping that this is going to be 4a minus square root of 9 is 3. So notice I'm just square rooting the first term and the last term. And then this one actually would be, because it would be quantity squared, so I would have it again. Now I like to write it out instead of using quantity squared. Now let's double check. If you FOIL this, you get 16a squared. If you do the outside, you get negative 12a. The inside is negative 12a, so that gives you negative 24a. And then negative 3 times negative 3 is positive 9. That's just easier than the whole modified diamond in the box. Now, I'm leaving this, well, I'm going to change it to times, but then I have to remember to flip this. So notice that this is a perfect square. This is a difference of two squares right here. So I'm going to follow the pattern. You can look back at the factoring flowchart if you need to. Difference of two squares right here. So we have, and I'm putting it in the bottom because I'm changing it to multiply. So we have 4a plus 3 and 4a minus 3. So those two are done and factored. Now, for the other two, if you take a look, they're not perfect square trinomials, and if you take a look, there is no GCF for either one of them. So we can do a modified diamond in a box, which is fine. So if you want to do that, I'm going to start over here with this 4a squared. So remember how we did that. We multiplied, to get the part that goes in the top, you multiplied 4 times 6 is 24, and then we had this 11. So I can see my numbers are going to be 8 and 3, but because there was a 4 there, I actually have to do the box. So we weren't done yet. So we have a 4a squared here. We have a 6 here. I'm going to put the 8a here and the 3a here. Now I can factor out, so I get a 4a, an a plus 2, and a plus 3. So I get a 4a plus 3, and I get an a plus 2. So that one's done. Remember that the reason why I flipped these was because it was divide and I changed it to times. So I've got one more to do. Now I'm pretty sure that when I break up this 4a, if I look at everything else, notice there's some options. I could do 4a times a, or I could do 2a times 2a. But all the other places were 4a. So I'm pretty sure it's going to be like that. If you do, you could just kind of skip to that and not do the modified diamond in a box. For those of you who want to do that, let me come down here. So we're going to have negative 60 and a positive 17. So we might have to think about this a little bit. Well, I can see 20 times 3. So let's make that a positive 20 and a negative 3 to get me my numbers. But don't forget the box. So we're going to have the 4a squared here and the negative 15 here. So we know where those go. So I'm going to put the 20a here, the negative 3a here, and now we factor out. So I get a 4a and an a plus a 5 and a minus 3. So we have 4a minus 3, a plus 5. All the hard part's done. Now we are just canceling things out. So I have a 4a minus 3. Those can go. Here's another 4a minus 3. Those can go. 4a plus 3. Those can go. This whole thing simplifies to a plus 2 over a plus 5. And do not cancel those a's because they are part of a sum difference. They are not factored. This is the answer. And that is simplifying rational expressions with multiplying and dividing.